Hello, my dear students. Today we are in lecture number 8. I am B.S. Pandey, your physics lecturer. Student, we have finished with concept of triangle law in last lecture. Today we are in lecture number 8 of vector, that is the vector analysis. Today we will study geometrical addition, how to add two or more than two vectors. The first we will study the triangle law, then parallelogram law. The first will be the triangle law, second will be parallelogram law, and the third will be polygon law. Those students have not understand very well about this triangle law. Today they will try to understand. They must pay attention over here. We are going to start with the triangle law of vector addition. Okay, what was the statement of triangle law of vector addition? We have studied the triangle law of vector addition. The two sides of two vector can be represented if two vector represented by the two sides of a triangle in same flow. All right, like this way. I'm having the vectors again. This is the three vector I'm having. If one side I have put over here and the second side in such a way that both are in same flow, then the third will be the vector. Remember, you cannot make this resultant like this one. Why? Because this all will be in same flow. Resultant should be in opposite flow. And the second thing which was very important, what I told you, the head of resultant will meet with the head of any vector and tail will meet with the tail of any vector. So in this way you have to find the resultant. All right, my dear student, look at here. I'm giving you here some example. Suppose the vector A and here the vector B. The vector, I can put this arrow anywhere over the vector. Okay, of course it should be at the top, but I can put anywhere to understand. Alright, now try to add this two vector to find the resultant geometrically. Okay, let me solve one question. This one is the A. Now where should I put this V? At the top in this way or at bottom? Exactly, the answer is at bottom, so that both could be in same flow. Now this dotted line is the resultant. Okay, now our next aim to put the arrow over this resultant. So where the resultant should be, in upward or in downward? And the answer is in upward. So this will be the direction of resultant. My dear students, you will write this is as R equals to A plus B. Alright, now I'm giving you classwork. Actually, after my lecture you will solve it in group by solving. Here you are in market of vectors. There are number of vectors are there. Okay, number of vectors are there in that market. You can see it is a vector A, B, C, and alright, it is D and E. You will pause the video and try to draw over your copy this one. Okay, and then you will solve this question. Now question, you have to show the resultant of the following vectors. Okay, find the resultant. So the resultant of following Alright, the first one, A and B, you have to add A and B and so the resultant. Second, A and C. In this way you have to make the all probable combination. For example, you all are science student, remember, A, B, A, C, A, D. Alright, next will be which one? Tell me. A, E, yes, A, E. Next will be, tell me, which one? Which one? Yes, B, C. Then next one will be B, D. Alright, in this way you have to form. I'm telling you, you will pause the video and try to listen and make the proper combination on so all the vectors using triangle law. The next one is B, E, then C, D, C, E, and then D, E. These are the probable combination. Okay, now I'm rubbing this one. Okay, let me take a simple test of yours. Okay, very simple test. Although we have discussed, but the very simple test, my dear student. Okay, this is the arrow. These are the arrow. Let me draw the arrow by red. And this way, this way, this way. Okay, I hope all are clear. Vector 1, 2, 3, 4. Alright, and this diagonal 5 and this diagonal 6. All vector I have represented. Now, I am going to ask which one will be the represented. First one, in triangle 1, 2, 6, 1, 2, 6, which will be the resultant? Okay, hurry up. Try to tell me the answer. Which will be the resultant? The answer is yes, 2 will be the resultant. How? You can see 1 and this is 6. This both are in same flow and this is in opposite. So this is the resultant. Alright. So this 2 is resultant. In same way, my dear students, try to solve again. I will not give you much time. I will give the answer. Okay. In 1, 4 and 5. Yes, hurry up. Which will be the resultant? Which will be the resultant in 1, 4, 5? 1, 4, 5. Which will be the resultant? Okay, let me give the answer. The 5 will be resultant. Yes, 5 will be resultant. How? Look at here. Am I right? The 5 will be resultant? Yes, student, 5 will be resultant. No, this is not the resultant. 4 will be resultant. Be careful. Look at here. 1. This is 5. Both are in same flow. So these two are the vectors. And then this 4 will be the resultant. Yes. Okay. Now, next test. Third one. In 2, 3, 5. Hurry up. 2, 3, 5. Which one is the resultant? And you have to go for the next one also. The next one is 3, 4, 6. Fourth question. 3, 4 and 6. Yes, my dear students. Tell me the answer. Which will be the resultant here in 2, 3, 5? So 2, 3, 5. Which one is the resultant? And the answer is 3. Try to find by yourself. Answer is 3. Now, in this one, try to find the answer by yourself. Okay, let me wrap this one. Remember students, here if this is the resultant, you can see the head is going to meet with the head. And this tail is meeting with the tail. Always remember, for the resultant only, the head will meet with the head of any vector and tail will meet with the tail of any vector. Alright, so let me wrap this one. We have done with the practices over the triangle law. Now you can find the resultant using triangle law. If you are able to understand here very well in the way the triangle law vectorization, then it would be very easy for you the parallelogram law and polygon law. So let me move for the parallelogram law. Parallelogram law. We know that the parallelogram having the 4 sides, all right, the properties, it is the 4 sides and the 2 consequent sides are parallel to each other, all right. Now the statement for the parallelogram law, we will break in 2 parts. That statement of parallelogram law, what is that? So kindly write down, students. I am telling you the statement and you have to write by yourself and then I'll explain. 2 vectors, if 2 vector represented by any 2 adjacent side of a parallelogram, then either diagonal will represent the resultant of that 2 vectors. This is the first statement and the second, the first part of the statement and the second. All the 3 vectors, that is 2 vector and 1 resultant, must be originated from the same point. You have to place the 2 vector and resultant in such a way all the 3's originated from the same point. Okay, this is the very simple parallelogram law. Okay, let me give you an example. If you are having the 2 vector like this one, A and B, okay, this vector, you have to add this 2 vector using parallelogram law. Okay, put this one vector A. Now you have to put the B in the way both should emerge out from the same point. All right, so you have to put B over here. You can see A is also leaving this point and B is also leaving this point. You cannot put B over here. If you will put B over here, then it will looks like triangle law. Now you have to make the diagonal, but remember, for the parallelogram you have to draw the parallel line like this one from here and parallel line like this one from here. So let me draw the parallel line. I'm not very well in drawing, so you will make by yourself in correct way, my dear students. All right, it is B virtually and it is A virtually. All right, and this is the diagonal. Now which will be the, you can see we are having the 2 diagonal, this one also and this one also, but we will take this diagonal as resultant. Why? In statement it is clear, very clear, that all the 3 vectors should be originated from the same point. That's why this is the resultant. All right, and what we'll write, actually my dear students, we'll write here the R is equals to A plus B. Okay, remember, triangle law is mother of all the laws, that is the parallelogram law and polygon law. You can see here the triangle also. Okay, you can see here clearly the triangle. Try to cover any half triangle, any one of the triangle, sorry, half not, but half of this parallelogram, any one of triangle, you will find the triangle law is equally valid. Okay, let me just hide this one. If I'm hiding this one, you can see, my dear student, if I'm hiding this one, you can see this is obeying the triangle law. Thus A and virtually B both are in same flow and thus R is resultant. Okay, yes, it means all the vector I have given here for the homework, all the vector you can add with the parallelogram also. Okay, using parallelogram law also you can use all that vectors. Okay, let me do one more question to clarify. One more question. All right, okay, one more example. This is one vector A and this is another vector B. We have to add this using parallelogram. All right, my dear student. Okay, so let me put, this is A and B should be originated from the same point. It means it has to be originate from the same point. So let me draw. This is B. I have to make the parallelogram. So I'll try. As I told you, I'm not very good in drawing, so you can draw by yourself in better way. Here, this is the virtual A vector, and this is virtual B vector, and the resultant. This is the resultant. I have given here the arrow over the resultant in such a way that all the three vectors looks like originated from the same point. Now if you will, this is the resultant, and we can write here the R as A plus B. If you will hide any of the triangle, you will find this triangle law is equally valid. Alright, so this is the parallelogram law of vector addition. Now I am going to explain you the polygon law. This polygon law will be used very feebly in your course, but you should know about that also. Here the polygon law. Using that polygon law, remember, using triangle law you can add maximum 2 vectors. Using parallelogram you can add maximum 2 vectors, but using polygon law you can add many vectors. Okay, more than 2 vectors, 3, 4, 5, etc. So you can add more than 2 vectors. To add more than 2 vectors, which law we should use? Yes, it is polygon law. Here we go with the polygon law. Now the polygon law, actually the statement of polygon law, if many vectors are represented by the different sides of a polygon in same flow, then closing side of the polygon will represent the resultant but in opposite flow. Remember, like this one, I am making here the polygon. This is the polygon. All the vectors should be in same flow. You have to place actually the vectors like they are in same flow. Here directly I have made the diagram. Suppose you have been given here the number of vectors A, B, C, D in this way, and E, then the closing side. Okay, what I had the vectors, after adding I have finished with the vectors. Now I don't have the vector to just make this one is closed, but this will close by a resultant. The closing side represents the resultant. Alright, and the resultant, all the vector you can see in the same flow, but this resultant will not be in same flow, it will be in opposite flow. So this will be the resultant. Now try to recall, I have told you that all the three vectors, all the two vectors law, here the law, triangle law and the parallelogram law, both can be seen by the triangle law. So we are going to find here the triangle law, but before that we can write here the R as vector A plus B plus C plus D plus E. Alright, now we are going to find out A plus B plus C plus D plus E is equals to R. Here, look at it. From here, can we draw here a line to get the resultant of A and B? Yes. And by triangle law you can see this is nothing but A plus B. Alright, now again try to find out. You can see this vector which is A plus B now. This is now A plus B, behalf of this two. Okay, this is A plus B, and this side both are in same flow, and this will be the resultant. And what will be the value of this one? It is A plus B plus C. Yes. Now you can make a dot line over here. You can see, my dear student, now these two sides are in same flow, and this is the resultant. And what is this side? Actually this is A plus B plus C, and this is D, then A plus B plus C plus D, it is the resultant. Now what is this side? Actually this is the A plus B plus C plus D, and this is E. It means using this two you will find the resultant. And finally we got A plus B plus C plus D plus E as resultant. So you can see here the number of triangles are there in this polygon. It means polygon law is also combination of many triangles. Alright, so this is all about the laws of geometrical addition of vectors. Okay, now we'll move to the next topic, my dear student. Remember, in parallelogram I have given you homework to add all the vectors what was I have given in triangle law. That is the same. Okay, and remember, you have to solve that question using proper pencil. This is your golden time, my dear students. Never neglect any homework. This is your golden time. Use your pencil, proper pencil. Give your time and try to make all the triangle and parallelogram. Don't avoid. Yes sir, I am now very excellent to make all the things. I got everything. Okay, do the practice. That will be very beneficial to you, my dear students. Never neglect any homework. Okay, now next. We are going to study here the displacement vector and position vector. This is very important. Actually, this entire vector is very important for not only the standard 11th but for the physics, as I told you, and you will study in mathematics also, my dear student. Here the displacement vector and position vector. All right, displacement vector or the position vector. Okay, my dear student, you might have remembered the unit vector I have discussed. If you are using the three axis, here the x, y, z, so in the direction of x we use to represent the direction I cap, am I right, and j cap and k cap. Okay, you should remember. We'll use this one. We are going to practice over this one, my dear student. Okay, now this was only to recall here. Before starting the displacement vector or the position vector, let me here do very simple questions. Okay, yes, you know very well about the coordinates. If I have given here the coordinate 2, 3, what does it mean? If I have given here the coordinate 2, 3, what does it mean? It means to reach this point from origin, you have to move 2 units over x-axis like this way and 3 units over y-axis. Am I right? Yes, this one is x and this one is y. And if I ask, so this point P directly from O, you will make this line. Okay, it is clear to everyone? Yes, it is very clear to everyone. Now the position vector and the displacement vector is very simple, very simple. I'm going to represent in vector, this point in space or the plane. First, we'll start our discussion with the plane. X, Y. This is the point P, X, Y. All right. It is a coordinate X, Y, and this is the point P. You have to represent a displacement vector. To move from O to P, how we have to move? Actually, we cannot fly directly from O to P. We have to go with the proper channel. We have to go with the proper axis. To move from O to P, we have to move x unit along x-axis. So this OP will be written as x. This is the vector. Okay, this is the vector. But what is this? This is the magnitude, not the vector. And we know that a vector should have magnitude as well as direction. So could you find the direction of this x? Yes, while we are moving x unit, in which direction we are moving? Along I cap. So we will write here the xi. Now plus, we reached to this point. Okay, now we have to move up. So we are going in which direction? Y axis. So it is j cap. How much unit we have moved? Here the y. So it is y j cap. And this is the answer. Okay, it was very easy, na? Yes, it was very easy. In same way, we will do some example today, and next day we will have very fun, will very enjoy to solve such questions which is based on vector. This vector is very interesting, my dear students. Remember, this is not very tough. You will enjoy if you will pay your full attention over here. This is Z, y-axis, and this is x-axis. This is origin. Alright, let me write the A, B, C, D. Here the A, this point, B, C, D. Here E, F, and G. All the side, this structure is a cube, okay? Cube of side A. Alright. Now I am asking the first position vector OD. What will be the position vector OD? Could you write OD? Yes. Look at here carefully. You have to reach to the point D. From where? You have to reach to the point D from O. So try to move from O to D. You cannot fly directly to D from O. You have to just pick proper axis to go to the point D. So you will move from O to F, then F to D. Or you can choose another way. You can go to A, then B, then E, then D. Okay. Answer will be same. Okay. How longer and how much you are traveling in this cube, over this cube, it doesn't matter. The answer remains same if you are using properly. Alright. So the short path we will decide. We are not fool. You have to move from O to D. So the OF and FD. OD will be OF plus FD. Alright, my dear student. And what will the answer? OF unit is A. Along x-axis we are going I cap, plus FD. We are moving along the y-axis. So it will be AJ. This is the answer. How much easy it is now? Now the second one. Try to write the answer. I am writing here every. You have to write OE. Hurry up. Open your pen and paper and start writing. Don't wait for my answer. DA. Now you have to move from D to A. And the fourth one, it is CG. Okay, I will give the answer of this all, but I'm giving you a few minutes to solve by yourself. And there will be homework also on the basis of this one. This is your practice. Alright, my dear student. Okay, now let me write the answer. OE. From O to I have to move E. So I move OF. It is AI plus FD. It is AJ plus DE. So AK. Remember, it could be plus or minus, but I'm writing always plus. Why? I'm moving towards the positive axis. Here, if you're moving from D to E, look at here. This is the Z axis and this will be the positive K. If you need to move from A to O, that is E to D, then you will have to write minus K. Alright, because I'm moving from D to E, that's why it is plus K. Now, this is the answer. Now, DA. D, where it is? Yes, D. And A, this one. Okay, DF. In which direction I'm going? Downward. If I go in upward, then it is plus J, but I'm going downward. So the minus J. So minus AJ. Minus AJ. Now DF, FG, it is positive. So the plus AK. And GA. So it is minus AI. Alright. Now CG, the last one. Okay, CG, C, where it is? Yes, C and G is here. So CD, AI, DF minus AJ, and FG, it is plus AK, and these are the answer. Alright, my dear students, now I'm giving you a homework. Let me wrap this one. Okay, next day we'll study how to break a component of a vector. How to break component of a vector, that is the very important. But before solving few more questions of displacement and position vector, we will study in very detail about this position vector, my dear students, remember. Okay, so this is your homework. Again, you have to find the position vector. I will ask z-axis and this is x-axis. There is a story behind putting this xyz also, my dear students. You cannot put xyz anywhere. Okay, this is 7 unit. All right, this is 3 unit and this is 4 unit. Along the y-axis it is going 4 unit. This is the 7 unit. Remember, this one is the 7 unit and this one is the 4 unit and this one is the 3 unit. Now let me write the name A B C D, A B C D E F G. All right. Now the question, part. Question 1, it is OE, second OB, third BF, fourth DA, fifth CG plus FA, sixth EO minus DA. All right, so this much. This is your homework. Okay, student, do till here. We'll move in next class, the next topic, or the displacement and position vector. Okay, my dear students, thank you very much.